This is part A of making an algorithm to create an electromagnetic wave. First, if you're not already there, go to pencilcode.net and log in. Now we're going to create a new project and call it Electromagnetic Wave. To draw the wave, first you need something to draw with. So let's go to Art and pull out a pen that's going to be purple and 10 pixels wide. Next, let's pull out a speed block so that the turtle moves a little bit faster while we're testing things out. Now we want to create something in the shape of a wave. We can't create the perfect rounded edges, or at least not very easily, but what we can do is create an approximate image of a wave. So if we're in the move blocks, we can go forward, turn right, go forward, turn right, go forward, and that should give us the first half of a wave. Let's test it out. All right, that looks correct. So now we can continue with the bottom part of the wave. And instead of add another forward block, we can just change this to double the value. And then turn left, forward, left, forward again. And that will give us the full wave. Now let's move on to part B, adding a loop. So to add a loop, we're going to go to the control menu, and we're going to add a for loop, dragging the block out. What a for loop does is it repeats code that's within it for a certain number of times. So in this case, it's going to repeat code for 3 times. So if we highlight our code that makes our wave and drag it into this for loop, it will repeat it 3 times. All right, it looks like it repeated it 3 times, but it moved off to the right of the screen. So let's add a move to block so that we can start a little bit to the left. So if we want to go to the left, we have to do a negative x value. And then we don't want to move up or down, so just a 0 y value. Let's try that out. Great. So now we have our wave repeated 3 times. Moving on to part C, which is adding variables, allows us to add a little bit more automation to our code. So currently, if we wanted to change the amplitude of the wave, we'd have to go through and change each of the values related to amplitude each time. So let's try that. Oh, and I messed it up, which is part of the problem of doing this manually. So now we have our wave with our shorter amplitude. However, instead we can add variables so that this becomes automated. To add a variable, go to the operators menu and drag out the first block that you see, x equals 0. And we're going to name this variable amplitude. So you can just type where the x is, amplitude. And let's say that we wanted it to be 100. The other variable that we're concerned with waves is the wavelength. So we're going to create a wavelength, and we're going to have it set to 100. So now, where we have our move forward, instead of having a static number like 50, we're going to call the value of the variable. So every time that we move forward and we call the value of amplitude, it will go up and grab the value of amplitude and stick it in here. So let's do that for each case where we're dealing with the amplitude. All right. Well, here we needed the amplitude multiplied by 2 because amplitude is only the amount above or below baseline. So we need amplitude times 2 here. And now we have our wave back to normal. We can do the same thing with wavelength. Just typing in these numbers, or typing in the name of the variable where we want its value to be called. Wavelength is the full value of the wave. So to do only half of the wave, we need to divide it by 2. And now we have a wave that, if we change the value of the amplitude or the value of the wavelength, it will keep its properties and adjust accordingly. Moving on to part D, which is updating variables within the program, helps us add another level of automation. So if we want our wavelength to decrease in value as it goes on so that it moves through different levels of the visual light spectrum, then at the end of the for loop, we can decrease the value of wavelength. We can do this by adding a variable block that is going to be wavelength, and it's going to be the current value of wavelength minus, let's say, 3. So what this block does is it says the new value of wavelength is going to be the old value of wavelength minus 3. And so each time that this runs, the value of wavelength is going to get smaller and smaller. You can see it's starting to get smaller, but we're going to have to repeat this a number of times to really see it. So let's repeat the for loop 15 iterations instead of 3. So you can see it's getting smaller and smaller. It's getting a little bit convoluted with the width of our pen. So I'm going to go back to our pen block and change the width to be 3 instead so that it's much finer. Since we're running a longer program, I'm also going to ramp the speed up a little bit to 20. And let's repeat it 25 times. Okay, so the wave repeated so many times that the value of wavelength turned negative, and the wave started repeating back on itself. So what we can do is, instead of a for loop that repeats for a set number of times, instead we're going to use a while loop. And a while loop says, while a certain condition is true, keep repeating the loop. Once that condition is no longer true, the loop will terminate, which means that it'll stop running the code. So we're going to do while wavelength is greater than 1. And so this currently says less than 1. So what I can do is I can either drag this part out and drag in a greater part. So while wavelength is greater than 1, or if I was getting comfortable with pencil code, one of the things I like about pencil code is that you can switch it to a text-based language. So if you click this little block down here, you can switch it to text, and then you could more easily change the direction of this. And then you can always switch it back to blocks. It's not a one-way road. So let's take this code and stick it in our while loop and get rid of this for loop. So we can get rid of any blocks just by dragging them across out of the workspace, and that will delete them. So let's try this. Okay, so as soon as the wavelength got to less than 1, the loop stopped, and that's what we want. Now that we have our wavelength updating automatically, we can change the pen color based on how long the wavelength is. And the way that we do this is with if-then conditional statements. So conditional statements say that if something is true, then something else will happen. So we're going to have a number of these because we have to go through all the colors. So instead of using a plain if sentence or block, we're going to use an if-else block, and that allows us to build multiple options into the block. So we're going to drag this out and say that if the wavelength is greater than, let's say, 40, then the pen is going to be red. So to do that, we go back to our art menu and we drag a pen block, and the pen will be red and 3 pixels. Otherwise, the pen will be purple and 3 pixels. Well, this isn't quite right because it says wavelength is 40. So let's go to the text-based side and change this to if the wavelength is greater than 40 and test that out. All right, so we have a clear marker from when the wavelength is greater than 40, it's red, and then after, it's purple. Now we just need to add in all the intermediate steps. So we have if and else, and the easiest way to fill out the rest of this is in the text-based side. So instead of if, and at the end we have else, in the middle we need else if. So else if wavelength is greater than 35, then the pen is going to be orange and 3 pixels wide. Then else if wavelength is less than or greater than 30, the pen is going to be yellow and 3. Else if the wavelength is greater than 25, pen will be green and 3. Else if wavelength is greater than 20, the pen will be blue and 3. Then at the very end, else the pen is purple and 3. So there's a number of ways that you could actually set this up, but the way that we've done it, because we're starting with a longer wavelength to a shorter wavelength, is as the wavelength passes through these different thresholds, it will change the color. So let's see how that looks. So you can see the wavelength as it gets shorter, it changes into these colors based on shorter wavelengths in the visible light spectrum. And that's how you create a simulation of the visible light wave.